joining my session. My name is Michał Brygidyn. I'm a security researcher, and this presentation is a result of my research. I want to show you how easy it is to hack into someone's cloud account. As AWS ambassador, my end goal for each of these scenarios is to get admin access on AWS account. And there are many different levels of experience and the knowledge needed for each scenario, but let's start with a very simple one, HTML. Why? Because you just need to view the source code, and you can find credentials to AWS in the source code. I don't know why, but people think that if it's code, it's hidden somewhere, but it's HTML, so it's not hidden. There is a comment with AWS access key, AWS secret access key, everything you needed to communicate with someone's AWS account. And there was even a note, a remove before production release, but it was not removed. So in this scenario, step one is the only step because it gave me admin access to AWS. These credentials were credentials of IAM user with admin policy attached. What went wrong here? The team that developed the code decided to add a node for the next team that was testing it or that was developing this feature, the next part of this feature. They decided to leave the comment saying, hey, these are credentials that we were using. Use the same, but maybe then remove this before you release it. But they forgot it, and the next team didn't know that it's there, so it was just left there. Next one, a very interesting one, because you can find many different kind of information on GitHub. And this one is a bit complicated. It can be as easy as finding a config file with all credentials there, but this time it was a config file with variables saying that it may be AWS access or secret key, or it may be a different login and password for different portal, but it was encrypted. So what to do if you find something like that on public GitHub? You look for a function to decrypt it in the same repository. And there was a Java class with the full decrypt function and the secret key hard-coded in the same file. So easy way to extract everything. These are examples from GitHub of what you can get by looking at different files. These are public repositories. People are using public repositories for their apps. I don't know why, but it's a lot of this there. So if you look for it, just remember to sort by creation date or index date to see the newest on top. And when you find something like that, in this case, it was Office 365 login and password, because there was a functionality to send emails. And someone decided to use their own login and password for Office 365 just to use SMTP and send emails from this application. And the first idea, oh, I can log into someone's Office 365, maybe even open Teams. And if you have access to that, you also have access to Azure AD and the list of all users of that organization. Then you can see the organization tree and find the CTO, CEO, whoever you want, and just say, hi, I'm no reply at yourcompany.com. And there was also a SharePoint available for that user. And on this SharePoint, there was a guide how to install and configure Jira. And it was a real guide from Jira configuration for that company. And someone who created it was probably asked to put every step that they followed into that guide. It was a PDF file. So they did that, including the admin login and password at the very end of that PDF file. And it was Jira, so it was public. And there was, as admin, you have access to all projects on Jira, and there was a project with AWS in name. And there was also a task to create IAM user for external service. And in this task, there was a comment with IAM user access key and secret key. Nothing else needed to get admin access, because the user was created as an admin with everything possible. What went wrong here? First of all, hard-coded credentials. Don't do that. If there are config files and you want to hard-code something, use environment variables instead of just values for these credentials. Because if there are values in this file, the file is in the repository, someone may see it and use it, either the external attacker or maybe malicious insider. Then if you use encryption in your functions, it's not a good idea to store the encryption key, the secret key, in the same file. And the reason behind that was that the team said, oh, it's used only here, so why do we need to store it somewhere else? So maybe because it's easier to hack it if it's in the same place. And Git history, a very common mistake if someone pushes sensitive data into a repository. They maybe when they realize that, they overwrite it, and that's all. If it's overwritten, maybe nobody noticed that I made that mistake. And that's not a problem if you rotate the credential, rotate the password, change it. But if you leave it there, Git history remembers everything. That's why we have Git and version control. So in case you accidentally push something to a repository that shouldn't be there, override it, but also rotate the credential that was pushed. Next thing, bad tool selection. If you are using public repository, then the question is why. If your company doesn't have own private one, maybe it's a good idea to create one, a paid version of this. Or if it's public, then use it like a public repository with code that doesn't contain any sensitive information inside, especially login and password for your internal systems. And if you need to share credentials, don't do this by adding them to a PDF file or sending both using the same channel, for example, Slack or Teams or even email. Because maybe the one that received the message from you currently shares his screen on a video call and not the one application window, but the whole screen. And the message was visible there, so during his meeting, someone may already try to use this. Instead, try to send them using secure channels, like, for example, share the credential from LastPass, or send a login using Slack, and then password using email, maybe even using one-time link that was generated just for this. And when the guy clicks the link, he can copy the value, and the link will not be available for the next one clicking it. And also, there's a lack of security awareness. If you decide to put sensitive information in a place that's possible to open and to view by many visitors, like SharePoint and a PDF file with login and password, that's already a problem. Same with Jira and putting credentials in comments. If you see it, try to do something with it. Educate people doing that there are better ways of sharing sensitive data. And maybe even ask them not to do that if they are generating these files, PDF files with guides, with step-by-step guides. Ask them to not disclose any sensitive information in that. This particular team created more than one PDF. It was not only Jira, but many other systems as well. It was a junior admin asked to do something, so he did what he was told to. And also using own accounts for functionality like sending emails from your application is not a good idea. There's service accounts to be used, but sometimes teams don't even know that there is something like service account, so they just use their own login and password, and anyone in the team may use that against them. Next scenario is dedicated to Symfony Profiler. Symfony is a PHP framework, and Profiler is a developer tool for debug and other purposes. And if it's publicly open, you can see all server parameters, all environment variables for that application. Also, you can preview parameters YAML in some versions of Symfony and Profiler. But the most interesting part of functionality for me is request history. because you can see the history of all requests made to that application, including post requests with login parameters. So I extracted some parameters from that. Here's an example of what you can see using the profiler. The first image, S3 credentials. So yeah, we already get S3 access on AWS, but it's not admin yet. So we need to find another way in. But the second picture is a login and password to internal system, and it was in plain text. So let's check that. Internal application and admin credentials. These admin credentials were working on a dev environment because this was a dev environment. But if you see that it's dev.example.com, maybe try the same credentials on example.com without the dev, so the production one. It worked. So I was able to get access to internal application with a single sign-on available to many different internal apps, including production CRM, but also webmail. So I went that way and opened the webmail. And on webmail, I noticed a lot of messages from AWS, like invoices, like trusted advisor reports. So first thought, maybe it's a root user email for AWS account. So I went to AWS portal and tried to reset password for that email, and it worked. So on that webmail, I received a message from AWS, click here to reset your password, what I did. And I created a new password for that user, for that email, and logged in. There was no MFA configured, so it was that easy to get to a root user. And it wasn't just a single account. If you work with AWS, you know that there are organizations that allows you to create many different accounts under the organization. And this was the root user on the organization master account. So with all features enabled, I was able to get admin access on all current and new accounts under this organization. So all data there was mine. What went wrong here? First of all, production data on a non-production environment. It was a full database copy on this dev environment, and this included users with logins and passwords. So the password that worked on dev also worked on prod. And even if you don't have your copy of a DB on a dev environment, there are many cases where you use the same password on all environments because it's easier to remember. This client, that's password like that, and even if it's a different subdomain, it's same password because it was saved in LastPass or any other password manager. Don't do that because if you don't have your non-prod secured properly, then the password may leak and it will work on prod environment as well. And also, not in this case, but a very common case that companies are using a single account, single cloud account with many environments there, not only prod, but different development environments, everything on a single account. And that's not a good idea because if I get access to AWS, for example, using non-prod resources, I can get access to prod resources as well. And then sharing the same email, registering different services using the same email, because why not? We have everything in one place. As a management team, we know what to do. And the same email was used to register AWS master account, GitHub organization, and it was also one of the administrators of the Office 365. So everything needed to compromise the company. And sometimes these emails have a shared password between team members because it's just a simple inbox, and maybe someone will be on vacation and someone else should have access to that, and the company didn't know about distribution lists, so they decided to go that way. And yeah, that's not a good idea because then when you share the password with a team, nobody feels responsible for the account and for the password, so they will never change the password. So it will be valid for a few years until they stop using the service. And no MFA. If there was MFA in the first place for that root user, I wouldn't be able to get access to it. But there was no MFA configured because it wasn't required, so nobody used that. And also, when many people are using the service, they decide not to use MFA because you can, for example, attach only a single YubiKey, and who will hold that YubiKey if the team consists of 10 developers, for example. So don't use shared accounts. Next one, Kubernetes. Who uses Kubernetes? OK, I can see a few hands. With Kubernetes, recently it's the answer for all questions, even those unanswered, because customers think that Kubernetes is the answer to all, so let's go there. But if you do that in a way that you don't know what you are doing, you can end up exposing your Kubernetes API by deploying it in public subnets with role-based access control disabled, because, hey, it's a random IP, and only we know this IP, so who will access our Kubernetes API? If you have access to Kubernetes API, a random IP somewhere, you can extract secrets. These secrets are base 64 encoded, so they are not encoded at all. There are plain text config maps with all variables. Config maps are usually config files in your application at the end. And there is also access to a list of all pods with configuration of these pods. It looks like that. We can see all pods that were available on that cluster. We can see config map with some sensitive data and, for example, email addresses and secrets, some passwords, usernames for different services. Also, AWS access and secret key for S3 access only. And S3 is not enough. We should dig deeper. But it's that easy to extract something. And there are new clusters exposed every day. I have a scanner running every week. And every week I have like 70 new records of IPs with public Kubernetes clusters. So people are still doing this. OK, let's go to secrets. As you saw on the previous slide, there was already access to S3 possible by using S3 access and secret key. And there were also Jenkins credentials for admin. And the Jenkins, it wasn't publicly exposed, but it was running on one of the pods. So it was possible to forward port 8080 of the Jenkins to my local host. And thanks to that, I was able to open Jenkins app on my machine, even though it wasn't publicly available on the internet. And with Jenkins, there are many ways to extract sensitive data. First of all, workspaces. In workspaces, you have access to the source code of these projects that you build, that Jenkins builds for you. So you can see if there are any config files, .env files, maybe some instructions in PDF or any other YAML configuration files. And I found another set of access and secret key. This one was for Lambda access and SQS, still not admin. There are also GitHub credentials in Jenkins credentials, because if you use Jenkins credentials to store your login and password or keys, and you have admin access to Jenkins, you can easily decode the values for that. So it was possible to access more, but that wasn't my goal. I wanted to get access to AWS as admin. And Jenkins, as a tool to build your infrastructure on AWS, usually has high permissions, if not admin. So I tried to use Jenkins console to ask for metadata. And yeah, there was possibility to extract some temporary credentials from Jenkins app, but this wasn't enough because it was configured in a way that wasn't admin yet. But using kubectl, you were able to log in to open bash on that pod with Jenkins, and there was a user with full admin access to that cloud account. That easy. So what went wrong here? First of all, public resources. I don't know why, but many teams decide to deploy different parts of their infrastructure in public subnets, even though it's not part of the infrastructure that should be in public, because it's not used by customers, but just by development teams. And they don't know that public resources are public. I don't know why. Limited scope of pentest is another reason. Companies who need to run pentests sometimes decide not to test non-production environments because only production has to be compliant, so let's stick to it and pay less for the whole pentesting activity. And sometimes just risky design because there are many different teams working from different places, and it's cheaper to make it public instead of creating a VPN, for example. Next thing, disable security features. There are security features enabled by default, but they are sometimes weird or they are complicated, and the teams decide to disable them because, hey, only our team knows the IP, so who will hack us? Let's disable it, it will be easier for us. And then, if they are using these functionalities to store credentials or to store config maps, these are not encrypted because if we encrypt it, we need to decrypt it somehow. We need to store the encryption key somewhere. And yeah, the most funny response I got why the team didn't encrypt the data. Hey, it's already in the cloud, so it should be secure, but it wasn't. The cloud itself didn't encrypt your data just like that, if you don't enable it. And no firewall. As before, teams all around the world or home office with dynamic IP, so we need to open everything to let them work. There are no ways to secure it with no money. And principle of least privilege, that's the most important one, because if this was followed, then all my hacks would not be possible. Admin for all, that's the most common version of giving access to cloud developers, because they may need it one day, and instead of asking us again, let's give them admin. It's easier for them and for us. Yay. And unprotected CI/CD tools. If you use tools like Jenkins or other tools to build your infrastructure, these tools usually have high permissions. And then you need to know that whoever has access to these tools can either run different jobs to create a rogue machine in your network or in your infrastructure, or they can, for example, push something to a repository, to a branch that will trigger the tool to deploy something. So yeah, this tool has to be secured, and it has to be secured properly with all layers on it. And the last but not least, running apps as root. Yeah, it's easier to just run the containerized app as root because then all commands work. But it's not that good if someone else gets access to your application, to your pod, because all commands will work. And that was the last one from my presentation, but it's not the last one yet. It was, but there are more. With not entirely the same slides, but I will show you other ways in. For example, the outdated software running on cloud servers. There was a bug in Atlassian apps in 2017 that allowed anyone to use Jira or Confluence to use it as a proxy. So you can ask Jira server to open any address, like Google, like whatever you want. Also, internal cloud metadata address. And thanks to that, you were able to open Jira and ask Jira for this metadata to get temporary access and secret key and the token to act as a Jira machine talking to AWS. As you can see, I don't know if the laser works. Last updated date, it's today, because this screen was today in morning, and the version 7.3.3, it's very old version of Jira. There are many of these still running there, and it's not only this one version, and there are like 10 affected versions, still a lot of them in the cloud. Next one, admin credentials logged during the installation process. This one is something from my audit at the customer side. I was given a view-only or read-only access to AWS, and I was asked to find a way in. So I checked many places, and then I went to CloudWatch, the service to aggregate logs. And there was a log from Jenkins, from installation of Jenkins. And the log was created by Automatic Tool that created Jenkins and then created admin user on Jenkins and logged admin login and password. Jenkins was publicly exposed for a company, so I logged in, and voila, I had admin access to their AWS account, starting from just read-only. No screenshots for that. Next one, misconfigured virtual hosts. This one is very, very old. I started from that, from looking hosts with directory indexing enabled, because when you find a host like that, for example, your usual vhost points to one direction, but this misconfigured default vhost points to a direction above that. So then you end somewhere here instead of web or public. And as you can see, there's .env file with a lot of interesting configuration variables. And next one, debug pages and connection strings. This one is from Python Django, but there are many different frameworks with debug screens and variables exposed just like that. But in Python, there is in Django there is a debug page. And there is a regex that changes all sensitive variables into hidden text. If they see, for example, key in the variable name, they will change it to, they will hide it. If there is password, they will hide it. But take a look at celery broker URL. No key, no password, just a broker URL that consists of AWS access key and secret key. Nothing else needed. If the company knows what they're doing, they use IAM user with a policy that allows the application just to talk to SQS. But if they don't know what they are doing, they can put whatever they want here and the user with any access. One time I found even access and secret key of a root user of the AWS account. And that was really the last slide. Thank you. I see that we still have some time for questions. Anyone, anything?
So please raise your hand if you have a question, and I'll give you the mic.
Hello.
Hi.
I have one question.
Sure.
Because you have shown us a very wide spectrum of security issues related to clouds. What would you recommend for developers to choose some benchmarks, or what is your opinion about these benchmarks or Microsoft?
Yes, these benchmarks are for sure very good, but if you already know these benchmarks, you usually don't do this kind of mistakes. And it's a good idea to do anything to learn, to gain the awareness. And if you are aware, then even if you don't use benchmarks, you still know what to do and what not to do. But yes, these benchmarks are really good if you are configuring your virtual machines, for example.
Thank you. Anyone else?
Are you doing this research for bounty hunting?
Yep.
Or? Okay.
Exactly.
Yeah.
What I do is I don't target companies, I target a vulnerability. So when I find a vulnerability, I create a tool to find all affected sites or applications, and then the problem is that I don't know who's the owner of that. So I need to dig deeper to find, for example, email address or a domain. And when I find them, I contact the data owner. I aim for C-levels, because when I report it to developers, the information disappears in the organization. But when I target CTO, for example, or CISO, they usually know what to do.
So I'm pretty sure you use OSINT tool to just find some stuff. What's your favorite OSINT tools to use to find some stuff?
Census, Shodan, Binary Edge, and I also use ZoomEye, but now my tools stopped working on that, so I decided to drop that. But
Thanks.
Binary Edge right now.
Binary, yeah?
Yeah.
Hi, why your investigations end up in AWS all the time, not in other cloud providers?
So I'm AWS ambassador, and I know AWS a lot. I don't know other clouds that well, so that's why I focused on getting access to AWS. But as you could see, I also got access to Office 365, and this user had access to Azure AD and probably other Azure services as well. And I also encountered many Kubernetes running on GCP, so it was possible to extract from GCP whatever I wanted, but I don't know that cloud that well to show you how to do it and what to do with it. But it's also possible. That's just an example. If it's AWS, Azure, or GCP, no difference. The same mistakes everywhere. OK, thank you.
Thank you, Michał.